Hello, everyone. My name's Tegan Clary, and I head up the marketing team at Unchained Labs. I'll be your moderator today, and thanks for joining us. We will have a Q&A session at the end of the presentation. To ask questions, all you have to do is click on the Q&A button in your Zoom navigation bar. It should be at the top or bottom of your screen. Type in your question. When submitting a question, try not to do it anonymously in case we need to follow up with you or we don't get to your questions. We'll be able to follow up with you afterwards. So go ahead and do that in the Q&A and we'll know it's you and we'll be able to get back to you. We'll get to as many of the questions as we can today. And now I'd like to introduce Martha Perez, Marketing Director at Unchained Labs. Hey, Martha, how are you?
Hi, Tegan. Good. And you?
Good. We're both looking bright and green today. Love it. Today, Martha will walk us through one of our brand new products, our LNP maker called Nunchuck. She'll give us some details on how Nunchuck works, and will show us data generated from LNPs on Nunchuck, basically in a complete workflow on how to do total flow rate screens, and then scale up to larger volumes with your LNPs. And she'll also show some characterization on one of our other products, which is Stunner. Now I'll hand it over to Martha. Martha, it's all yours. I'll be back at the end and we'll do Q&A together. Okay?
Thanks, Tegan.
You bet.
Let's get started. I am super excited to share with you guys about Nunchuck today. And let's see, as this guy would say, researchers only want instruments with good skills, and Nunchuck has great LNP making skills. And I look forward to showing you guys all about this today. Now, we're going to start with this little pest. Everybody knows that this is the COVID-19 virus. And we all know how this turned our world and our lives upside down. And it was very important for the world to come together to use all of our tools to beat this virus back. One of the most important tools we've used has been vaccines. And to date, over 12 billion doses of vaccines have been administered worldwide. Over 70% of those doses have been mRNA LNP vaccines. And while many thought that they were new and just invented, they were actually created and discovered over 30 years ago. But why hadn't we heard more about LNP vaccines or LNPs in general? Well, just like that cake that you tried to copy off of social media, it's a lot harder to make than it looks like. Well, LNPs are actually very useful molecules, and they have a wide range of usefulness due to the fact that they have a lipid layer, which many different lipids could be used for, and a payload, which is what's inside the lipid nanoparticle. That payload could be DNA, it could be protein, it could be RNA. Actually, probably any active biopharmaceutical molecule can go in here. So they are quite versatile in what we can get them to do. Another factor of LNPs is the size. And when you vary the size, it also affects what kind of cell type it can go into or what organ it can go into. So as you can see, they are very diverse in what we can get them to do. Now, how are people making LNPs now? Well, current solutions for scientists fall short. Why is this? Scientists currently have to deal with either kludgy, homegrown messes, things that they have to deal with, lots of tubing that can get tangled, that needs to be changed frequently, or they have to deal with buying one box where they can do small volumes and a screening application. And then when they want to scale up in volume, they need to buy a bigger, much more expensive instrument. Well, Unchained Labs has solved this problem. And today you guys are going to get your sweet Nunchuck skills. Nunchuck is Unchained Labs' LNP maker that makes 50 to 200 nanometer size full LNPs. You'll be able to screen 8 total flow rates, or TFRs, in 10 minutes And you can make from 0.5 to 200 milliliter formulations. Now, how does Nunchuck do this, you might be asking? Well, the Nun gets it done. You will put your organic and your aqueous formulations in syringes and lock them into the Nun. And as you can see, the Nun contains the entire fluidic pathway from the inlets to the outlets. And in between, we have this microfluidic chip that is completely novel. And we have a window into the liquid fluidic pathway of the microfluidic chip, where we use a camera to do automatic priming to optimize how many LNPs you're going to be able to get. We have these microfluidic chambers that provide the turbulent, non-turbulent chaotic flow to get the highest quality LNPs. And as you're all familiar with Unchained Labs products, our software is super easy to use. So white belts are welcome. This is an example of our screening application, where you'd be able to select your flow rate ratio anywhere from 1:1 to 10:1, and then how much sample you want per total flow rate that you're testing. And you can test up to 8 flow rates, and you can select how many total flow rates you want to test. You can easily either use our default parameters for pre-run and post-run waste, or you can select whatever parameter you want there as well. You'll be a black belt in no time. So now I'm going to introduce to you, as Tegan said, our LNP tag team, which is how our total workflow will work, where customers can make LNPs on the Nunchuck and then analyze them on the stunner. You would want to use the stunner for dynamic light scattering to determine size, and the polydispersity index, which is a measure of the quality of the particles that come out. The next couple of slides is going to be showing LNPs that were made on Nunchuck and the data coming off of stunner. So with the screening, the TFR screening, you'll be able to hit your target. As you can see here, these are 2 experiments where we used either poly-RNA as a payload or mRNA as a payload. On the x-axis, you can see total flow rate. We varied it from 2 to 25 milliliters per minute. On the left-hand side with the hydrodynamic diameter, that tells us the size of the LNPs. And as you can see, the size of LNPs decreases as you increase total flow rate, as you'd expect. On the right-hand side of each graph, you see the Polydispersity Index Pdi. And because this is a small number, we know that these particles are high quality. And you can also see from our encapsulation efficiency data that we got the payload that we wanted into the nanoparticles. For poly-RNA, it was over 90%, and for mRNA, it was over 85% for every one of these. Now, when I'm screening for total flow rate, I'm picking out the instrument parameters that I want in order to then make either a little or a lot of our LNPs. So I can level that up to 200 milliliters. As you can see, the first column, that's the particle information that I got from the screen. And you can see that when I level this up in batches of 10 milliliters, you can see that all the columns are fairly equal. And the PDI, again, is a low number, under 0.2. So these are high quality LNPs. And we never saw a drop off in the quality of the LNPs that we make. And the encapsulation efficiency, yeah, we got it all inside. These reached the limit of the assay that we were using. So they're 99% or better. So what about other chemistries? Your chemistry, your choice. Here we're showing 3 different chemistries, DOTAP LNP, which is cationic lipid, MC3, and SM102, which are ionizable lipids. And as you can see again, with varying a total flow rate. As you increase total flow rate, the size of the LNP decreases, as you would expect. The encapsulation efficiency, again, every point is over 95%, and the PDIs were all under 0.2. So the next thing we asked is, are there other things that we can measure to ensure that these LNPs are behaving the way we expect? So you get LNPs just the way you want them. Here we're showing how we measured zeta potential. And as you can see, we tested the 3 LNPs in either buffers, pH 5.2, or in yellow, or another buffer in pH 7.4, which is in purple. As you would expect, the DOTAP, which is cationic, is not affected. The zeta potential is not affected by the pH of the buffer, but the ionizable lipids, those are affected by the pH of the buffer, with the positive zeta potentials in the pH 5.2 and zeta potentials in the neutral zone for pH 7.4. So these lipids, these LNPs are behaving exactly the way that we expect them to behave. So now you've got your sweet Nunchuck skills. Nunchuck makes LNPs from 50 to 200 nanometer size full LNPs. You can screen up to 8 TFRs in 10 minutes. It's really super fast. And then once you select your parameters for the instrument, you can then make either a little or a lot on the very same instrument. So when somebody asks you what a nunchuck is, you know to tell them, not this nunchuck, this nunchuck. And with that, do we have any questions?
All right. Well, hey, thanks, Martha, for introducing us to Nunchuck and how it makes LNPs. I think it is really cool how this system helps people identify that total flow rate and screens for them. I think we put a lot of time into that part of the instrument, and I know a lot of people struggle with that, and it gets it done a lot faster. So there are some questions. Let's go ahead and answer some of them. If anybody has a question, please don't hesitate to put it down in the little Q&A button and hit send, and we'll answer them right now. Okay. So Martha, the first one here in the list, let's just go top to bottom. Just remind us, what are the maximum and minimum volumes possible on the Nunchuck system?
Yeah, so the volume range is from 0.5 to 200 milliliters.
Okay, and then could somebody produce more than the 200 mil maximum with the Nunchuck? Is that some, like, you know, maybe somebody wants to push the limit of that? Is that possible?
Well, the 200 milliliters is the maximum that we tested, and we never saw a drop off in the quality of the LNPs. And when you want to make more, you're welcome to just do a new setup, new instrument setup, and you can hit the go button again.
Okay. And then what's the minimum and maximum flow rate on the system that are possible?
Yeah. So the minimum and maximum flow rates possible on the system are 0.5 to 30 milliliters per minute.
Okay. And then just kind of on an operational side of it, is there any way Nunchuck keeps records of what formulations have been used for screening?
Yeah. So as all Unchained Lab software, we keep the user's needs in mind. So we have 2 different options. You can either do your programming of your run super easy and just hit next, and it has generic names, so you don't have to spend the time to write things into the software. But you also have the ability to write as many details as you want with various different components and concentrations. So you can keep that information in the software and also in a report when it prints it out when you are done.
Okay. A couple of questions related to encapsulation efficiency. The first one is, did we use one of our instruments to measure that?
Yeah, so that's a great question. What we were using for encapsulation efficiency was a ribogreen assay with a plate reader, because that was the best way to determine encapsulation efficiency for the RNA LNPs.
Okay. And then maybe describe a little bit like where and how are the fractions collected for each flow rate in this screen, Martha?
So we have a collection vial for the sample and a collection vial for waste. And the instrument will run through one TFR and it'll pause and it'll ask you to just replace the collection vial. And you have your collection vial set up ahead of time, and you easily just replace it for the next TFR screen. And all of this, even if you do it in the maximum choices you can make, it'll take about 10 minutes.
Okay. And then back to really quickly to the encapsulation efficiency. In addition to measuring that, can we also characterize how many copies of mRNA per LNP it achieves?
Yeah, you could definitely do that with an assay, like a qPCR assay, if you wanted to.
Okay, so something offline with qPCR would be the way we would recommend to do that. Yeah, okay. And then has the system been tested for different pH ranges? Do we have a min and max, or do we have a recommended min and max?
It's not sensitive to pH ranges. In fact, we did some testing with pH ranges in the aqueous buffer that the RNA was in, and we saw through our development tests that pH of the buffer definitely affects the encapsulation efficiency. So if that's definitely a variable that someone can change in order to improve the encapsulation efficiency, but the instrument is agnostic to that.
Right, okay. The other couple other ones here, I think there's a couple in here about optimizing sizes of LNPs. I think if somebody, that's probably a longer answer to that question with regards to the chemistry and the flow rates. So if anybody wants to talk to us about those after the webinar, we'd be happy to take that as kind of a one-on-one conversation, because I think it's a little bit dependent on what you're using and how you're optimizing the lipid mixes that you're using and the payloads you're putting inside. So if somebody has a question about that, we'll take those offline. Okay. Martha, is the microfluidic chip disposable? How many times can people use it? Can people clean it? Like, what's the approach with that? With the Nun?
Yeah, so the microfluidic chip is provided as a consumable, and we'll let you know what we have validated for, which is the screen, a TFR in a screen. Separately, the preparatory mode up to 200 milliliters. And we have not done any validation in terms of washing the chip at all. That would be like an off-label use. Having said that, there's no barcodes on the Nun consumable.
Okay. A couple others here. There are a lot of questions. So just a little bit more on the Nun with regards to it being a consumable. At what point would somebody need to change the chip, change the Nun out, right? Maybe just describe how somebody would use it on a given day. Yeah. So a Nun, you can, walk up to it and you do your 8 TFRs screens to do a selection, to do a screen to see what instrument parameters get you what sizes. So in a day, you might want to take those 8 different samples and test them, on other instruments to fully characterize them. So depending on what you do, now I know if I have a very precious sample in the lab, then I'm not going to, reuse something that I'm not 100% sure on. So I would grab a new Nun and do a prep mode, whether I want to make a little or a lot on a preparatory mode. But again, that's up to the scientists. I would definitely not, run something that's a different chemistry on something that's microfluidics pathway. Right. I think this is a question with regards to like inline dilutions, Martha. Does the system allow for more than 2 inputs into the microfluidic chip? Yeah, simple answer is no. We know that some people do dilutions, but in our hands, we found very positive results that if we wanted to do dilution, we could, for example, have a diluent in the collection vial, or it takes so little time to make the LNPs that you could dilute right after they come off the Nunchuck. Right. I mean, I know we talked about it, looked at it, but with making, up to what, 10 different conditions in one run and being able to do those dilutions right there, it just made more sense that way. So I totally agree. Is Nunchuck intended as a discovery R&D tool, or is it GMP compliant?
Yeah, it's an R&D discovery tool. It is not GMP compliant.
Okay. And then a question about reproducibility, and I think this one, we may need to take this one offline, but I'll just go ahead and ask Martha for reproducibility for multiple runs, for PDI and encapsulation efficiency. I know we did multiple runs of all of our nuns, we did multiple runs in the same conditions, but maybe just tell people a little bit about reproducibility on the system.
Yeah, we tested reproducibility on multiple nuns and different days and different hands with different people operating the instrument. So we are very confident, and when we show the data based on like the TFR screen that I showed, for example, that is multiple experiments data shown on that.
Okay, good. And another one with regards to the setup of the system and consumables, what consumables, syringes, vials are compatible or needed to run Nunchuck, right? With the Nunchuck and the Nun, what are people putting their samples in? What are they collecting them in? Yeah.
So we tested the Becton Dickinson Luer Lock 10 mil and 5 mil syringes. There's so many choices out there that there's no way we could have tested them all, but that's what we recommend to use. And we tested about 3 different 15 mil conical vial tubes that are very common out there. And when you purchase your Nunchuck, we will have that information for you.
Yeah. Okay. And then some questions about solvents. What's the solvent compatibility of the cartridge? I think we've run a bunch, but maybe just give people a little bit of background on that. There was one question specific to chloroform, but I don't know if we've tested that. You might, but what are the solvent compatibilities, Martha?
Yeah, so the solvent compatibilities, off the top of my head, we know that it is completely compatible with ethanol, which is one of the most popular solvent for the lipids, and DMSO is also compatible. We're going to have a compatibility chart so that people can know this. There are a couple of other common solvents for organics that it's compatible. Chloroform, off the top of my head, I'd have to get back to you. Okay, perfect. Yeah, we've tested a lot, but we have not tested literally everything under the sun. So if somebody wants to explore that, we can definitely have that conversation offline. Right. Couple other ones here. Does Enchain sell any other instruments that can be used for the characterization of LNPs? I know maybe you can just refresh on Stunner, and then do we have anything else that can help people? Yeah, so we love the fact that we can provide a lot of different tools for our scientists. Stunner, like I said, it is a UV-Vis DLS instrument. So we use the dynamic light scattering for size and polydispersity. And then you can also, there are people using the Uncle for stability of LNPs, which is our used for thermal ramping, for thermal stability of lots of different biologics, proteins and AAVs and LNPs as well. You can also use Unchained Labs instruments like Big Tuna and Unagi for buffer exchange of LNPs.
Related to that, somebody asked about the hydrodynamic radius, or basically the PDI and sizing data that was shown in the presentation. I guess folks are wondering, is that straight up dialyzed LNPs, or basically straight up formulated LNPs, or is it prepared further with purification before we ran those? I think this is one of the advantages of Stunner, but I'll let you mention that. So yeah, so when the LNPs were prepared on the Nunchuck, we took them off the instrument, and generally for this data, we diluted 1 to 10. The reason for that is because many times when you make LNPs, the ethanol concentration is quite high. So we're also at very high LNP concentrations. Mm-hmm. So we do a small dilution and measure it right off the instrument. Right. Yeah, one of the benefits of Stunner is super, super short, tiny path length that allows us to see turbid samples, both for UV vis and for, because we're also able to do a payload quantitation on those LNPs as well, especially if it's RNA or DNA or protein. So it's just a big advantage with regards to the setup of the microfluidic chamber in the Stunner plates that allows us to do that. So I think it's a special combo, those two instruments.
Yeah.
Martha, what experience have you had with payload size limits? Do we have any recommendations on that at this time, or is that something that people would need to probably explore with their own special mixes?
Yeah, as I mentioned, there's so many different payloads you can put in LMPs. There's no way for us to test them all. So I wouldn't have like a smart answer for that right now. That's something that we would have to, work with the customers to test them correctly.
Okay. And then just along the lines of trying all the things, right? Apart from LMPs, have we tried anything else on this, or have we focused just on LMPs right now?
Well, we are focused on getting the best tools for our biologics customers, and they're mostly using LNPs. So that doesn't mean that the Nun couldn't be used in other ways, but that's definitely what we're focused on.
Yeah. Okay, great. And this will be I'll just make a comment here. There's some questions about manufacturing and, transferability of Nunchuck into manufacturing. And Martha answered the question earlier about that. We've really created a discovery development tool here that it can scale up to the 200 mils and maybe even further. That's as far as we've tested it. But right now, when it regards to scaling it specifically on this system into manufacturing, we're not there yet. So just want to make that clear to folks. But if you want to talk to us about using this for development, and then how the methodologies and flow rates, et cetera, could be scaled onto like a bioprocessing platform, we'd love to learn from you about what you're doing. And then we can talk about how our Nunchuck instrument may fit into your environment. Okay, so there's like 3 or 4 of those, and we'd be happy to have those conversations in more depth offline. Okay. The last question here, Martha, is related to the TFRs. Remind everybody how many TFRs can be used in one single run of the instrument, or do you have to do that one at a time? Maybe describe that experiment, and then we'll wrap up the webinar. Okay.
Yeah. So when you're doing a TFR screen, you can walk up to the instrument and you put your formulations in, your 10 ml syringe for the aqueous and your 5 ml syringe for the organic. Now, depending on how much volume you want to get out of each total flow rate, that determines how many total flow rates the instrument allows you to test. So if I were to tell the instrument, I want, let's say, 4 milliliters per total flow rate, then it's only going to allow me to test 2. Now, if I told it a smaller volume, like 1 milliliter, then it'll allow me to test up to 8. Now, just because I can do 8 doesn't mean I have to do 8, because we know that your reagents are precious and maybe you just don't have enough payload, for example, to have an experiment with that much volume. So you can select a lower number within that maximum that is allowed. And then you just hit go. The software walks you through how to load everything on the instrument. It's super simple. Honestly, we can teach anybody how to use it in like 5-10 minutes. Okay, awesome. And then just one, well, I'll add one more in here real quick. I'm going to combine kind of the last 2 that showed up here. Number 1, do we have any guidance on viscosities on the system? And then to add to that, do we have any recommended kind of off-the-shelf LNPs for people or lipid mixes for people to get started with using the system like that? Yeah, those are great questions. So viscosity, we are using syringes and pumps on those syringes. So it would be in the range of something that you can go, push through a syringe. And this is going through microfluidics, right? And you are going to want to have some mixing. So there is going to be some upper limit. We did not test a specific upper limit for viscosity before. Biologically relevant solutions that we tested, they have all worked. Now, the second question was about.
Just any recommendations for people to get started with
Yeah.
a lipid formulation for working with certain, with their payload maybe for the first time on the system?
Yeah, that's a good question. We also had to investigate different lipid mixes, right? We don't make reagents, so we have a starter kit, as most of our instruments do. We have included materials for our field application scientists to be able to teach our new customers how to use the instrument. In that starter kit, we're going to include a kit from Cayman Chemicals, which is SM102 lipid mix, which is one of the lipid LNPs that I showed data for in this presentation. And we found that that works really well. We will be helping our customers to learn how to use the instrument using that kit.
Okay, perfect, Martha. Martha, thanks for a great presentation and taking us through how Nunchuck works to make LMPs. I hope everybody that joined us saw how easy it is and simple it is, frankly, to use and to do screening and then do some scale up kind of in that development space. I think just as a reminder, you should, if you're interested, you can also talk to us about Stunner for analytical characterization. They are just a perfect combination of tools to be able to make them and then characterize them really, really, really rapidly. So thank you all for joining us today. If you do want to follow up with us or talk more about Nunchuck specifically or how to make LNPs and characterize them, we'd be happy to do that and would love to learn more about what many of you are out there doing. All you have to do is reach out to us at info@unchainedlabs.com or just put in an inquiry through our website. Again, thank you for joining us today, and we'll let you have the rest of your day and hope you have a good one. So thanks again, Martha.
Thank you.
All right, thanks. Bye-bye.